So what we talked about in the last segment was how neurons sit at a resting membrane potential of about negative 65 millivolts. And through mechanisms that we're going to come to, that resting membrane potential is just sort of it's the potential around which the neuron oscillates. So at one point it might get an input that if this is 0, that brings it closer to 0 or takes it farther away from 0, etc. And these small little potential differences, which are on the order of less than 1 millivolt up to, say, 5 millivolts, these small little potential differences can travel along the neuron. If these are the dendrites and here's an axon, they might travel, but they're going to peter out pretty quickly. So it's not a useful, it's not going to work to simply rely on these small potential changes. Now, if we have to go long distances. Now, one of the things that is so different about a neuron than any other cell type in the body is that these neurons, me the neuron, neurons are very long. Okay, so think about a heart cell. A heart cell is so big, it's contained in the heart. It ain't going anywhere besides the heart. A pancreatic cell is sitting in the pancreas. It's in the pancreas. It's pretty small. A lung cell, etc. Now, let's think about the longest neuron that we possess. The longest neuron that we possess is a cell that has a cell body right here, and it sends one process all the way down to the toe, and it sends another process all the way up to the medulla. So, depending on how tall this person is, in me, that's 1.5 meters, say. So 5 feet or something like that. But in a very tall person or even a very short person, that's still a lot of feet. That's feet long. So a small potential like 1 millivolt or 5 millivolts is not going to travel. If that's what we had to rely on, just moving from here to here, any message that started here would end there. It just wouldn't get there. It wouldn't get to where it needs to go. It needs to go here. And so in order to communicate within neurons, because neurons are so long, we use something called the action potential. And the action potential, in contrast to being this kind of small thing, it goes really far up and comes back down. So it's about 100 millivolts in height. So from the resting membrane potential to the top of the action potential, which happens at around plus, say, 20 millivolts or so, we're talking about roughly 100 millivolts of difference. And that can get communicated all the way up. That's not going to get lost. And what carries that action potential is that, remember that we looked at potassium being very high in a cell and much lower outside a cell. Well, the reverse is true for sodium. And so the sodium comes flooding in. And because it's positively charged, that's what takes the cell up to this very high membrane potential. Now, the ability for a neuron to communicate from here to here using an action potential it can do that, but that'll be a slow process unless we add one more thing, and that is an insulator, essentially a very nice insulator called myelin.